When I left off last week, I had a mostly finished implementation of my new AI design, but I had no idea how much of an issue performance and memory usage would be. I thought I'd just get it working and then run it under a profiler to see what needs to be optimized, but once I got just 3 actions implemented and started testing, I realized I'm going to need some big changes. The AI was already taking up to 23 seconds to figure out its next move, and that's probably not even the worst case. This week I'll talk about the steps I'm taking to improve the performance and memory usage of the new AI. In retrospect, I should have done some simple math up front to make sure this approach was even feasible. If there are 20 possible actions at each step and I limit the plan length to 10 steps, that's over 10 trillion combinations to try. Because I don't have a heuristic to help A* along, it's equivalent to a breadth-first search, and in the worst case I could have to keep track of something like 500 billion partial plans at its peak. Even if somehow each plan could be represented with just 1 byte, which I don't think is possible, that's over 500 gigabytes of RAM to keep them all in memory. That's not going to work. This grows exponentially with plan length, so I'm glad I decided to use short-term goals instead of planning the whole encounter. So I'm trying to make this as lean as possible. First off, let's say I want to limit the RAM usage to 1 gigabyte. If I optimize for memory, I could potentially represent each step in the plan with just 1 byte, assuming there are never more than 256 choices to consider at each step. If each partial plan also uses 2 bytes for cost and length, and I limit the plan length to 6 steps, that gives me 8 bytes total per partial plan. So theoretically I could fit 125 million partial plans, which would allow for around 40 actions to consider at each step. However, realistically I probably want to use a self-sorting data structure to hold the partial plans, so that will have some overhead. If I average at 32 bytes total per entry, I should be able to handle 31 action choices per step. These may not be my final numbers, I might change the memory target or plan length, but this at least gives me an idea of the kind of limitations I'll need. Unfortunately, this isn't going to be viable in GDScript. I did some experiments and it looks like there's over 800 bytes of overhead per object. GDScript isn't designed for high performance anyway, so I'm rewriting the AI code in C++. This will be my first time using C++ with Godot. I'm also making some changes to try to keep the number of action choices low, and do more with a small number of steps. For instance, let's look at the hack door action. Before, if no unit was at the door, it would suggest 2 locations from which it can be hacked. That's 2 action choices for 1 step, followed by hacking as the next step. Instead, I'll include movement in the hack door action as just 1 step, but with a higher cost to reflect the number of action points the unit needs to do it. If the unit will run out of action points by the time it gets there, I'll add a sort of end turn placeholder into that same step. Now it's just 1 option in the actions list and 1 step. I guess at this point we should think of these as meta actions. The complication here is I still don't want the AI units to end their turn in a dangerous spot. Rather than add logic to the actions to prevent this, I'm going to make a custom A* implementation for AI pathfinding that takes danger into account. Specifically, whenever the next step in the path would be the final step for a turn, it'll add a cost based on the estimated danger of that tile. In a sense, A* will strike a balance between the path length and end of turn danger. Goals will also be able to insert a step automatically when the final step is obvious, but only when that step costs 1 action point or less. That's because the goal shouldn't have to know about every possible action that could get it done quicker. For instance, an escape goal shouldn't automatically add 2 turns worth of movement when a mod might have added a teleporter that can get the unit there quicker. However, in case normal movement is the only way, goals can still suggest the full move path as an option to get weighed against the other possible actions. Even with at most 1 movement in the options list at each step, there are still ways we could find more than 31 possible actions. For instance, a player could choose to place more than 31 doors that the AI could hack open, so I'm going to have a priority list of things that should always be considered, and some other possibilities will be ignored if there are too many. A unit will always consider using equipped items, dodging, dropping a carried item if any, and any movement option provided by the goal. That's up to 5 actions per unit, but to avoid doubling that for 2 units, I'll have the AI focus on 1 unit at a time, and treat switching to another unit as another action option. Then I'll add possibilities from items on the board, things that could be picked up or interacted with until I hit the 31 action limit. I'll prioritize these by what's closest to the currently focused unit. I didn't include picking up cargo in the always considered list because I'll be splitting the steal cargo goal into 2 goals, one for picking up the cargo and one for dropping it off in the AI ship. That first goal can insert the pickup step automatically. I still have a lot of work to do on this, and there are some other performance improvements I'm considering. For instance, I may try pursuing multiple goals simultaneously on different threads, depending on memory constraints, and I'll try to pre-calculate things like ideal firing positions once up front. I should probably point out that most of what I've been talking about is the worst case scenario. Often the AI will find an optimal solution before exploring every possibility, or there will be fewer than 31 action candidates, meaning fewer combinations to try and less memory usage. However, even if a slow AI is rare, I want to put hard maximums on how long the player will have to wait. If I still can't hit a good worst case time with all the optimizations I can think of, I do have one last resort. I'll start by generating a default plan without GOP, a short-sighted simple plan that doesn't know about modded content, just have a fallback. This alone will speed things up because the main planning can abort any path that can't beat that default plan score, but then if the GOP-based planning takes too long, I can just stop it and use that default plan. I'm thinking no more than 5 seconds is an absolute maximum, but I might set that limit lower. There's not much more I can say about this until I get that C++ version implemented and see how fast I can get it. Meanwhile, I hate not having anything new to show, especially for the Patreon supporters, so I'm looking for small things I can do on the side while the AI is still a work in progress. Earlier in the week, I added a new debugging tool, a sort of cheat prompt, so you can instantly start an encounter of any difficulty level and give yourself extra money. Not too exciting, but next week I think I'll start by adding some new equipment or weapons to make sure there's at least something new to play with in case the AI continues to take longer than expected. That's all for this episode. Once again, you can support these videos and my game at patreon.com/Slockquake, and it always helps if you hit the like button, spread the word, or subscribe if you haven't already. And as always, thanks for watching.